Okay, general chemistry. This is another ionic compound naming and formula video. We've done simple ionic compounds, we've done ionic compounds with transition metals, and now we're going to do the simple 6 metals. In the last video, we talked about all this complication about transition metals, how you can't find their charge by looking them up, so it's got to come from the name, so we have to use Roman numerals and parentheses in the name, and then sometimes we have to go backwards in order to get the charge so we can put it in the name. Well, it turns out there are 6 transition metals where we can skip all that. 6 transition metals, 6, that are simple, easy, not a problem. They work just like the alkali metals and the alkali earth metals. We can tell their charge based on where they are on the periodic table. They always have the same charge. So let's take a look. It is these 6 here. They kind of have like a stair step in the opposite direction of the metalloids. And on the first step, we have silver. Here we have zinc and cadmium, and here we have aluminum, gallium, and indium. Now, there's a convenient pattern that develops. Silver always has a charge of +1. So this column in the step, now copper and gold, no. They are transition metals, they have variable charges. But silver always has a charge of +1. Zinc and cadmium always have a charge of +2. So we can always tell that zinc and cadmium are +2. And aluminum always has a charge aluminum, gallium, and indium always has a charge of +3. Not so for these guys down here. These guys can have different charges, but if they're in this 6, 1, 2, 3, 4, 5, 6, and the pattern is cool. The guy that's all alone in his own step is +1. Zinc and cadmium are together. They are both +2. And aluminum, gallium, and indium, the 3 of them are all +3. So if you can remember this step, and you can remember 1, 2, 3, there you go. You've got the charges of the simple metals, the simple 6 metals. Now, let's do some problems with this information. It'll be easier than the transition metals. So our first problem, what is the formula of silver nitride? First, as usual, we got to find the symbols. So silver, we look it up. Oh, it's our simple metal. Its symbol is that it is. Nitride, well, there is no nitride, but we know that the anions have an IDE ending, so if you go backwards from that, we know that this is nitrogen. Great. Silver and nitrogen. Now we need the charges. Silver, it's a transition metal. We can't look it up by looking, except that it's a simple transition. We can look it up. Silver is always +1. So, we will put +1 right there. Nitrogen. Nitrogen has 5 valence electrons. It has a high electronegativity, so it's going to gain electrons until it has a full shell. It's got 5, it gains 1, that's 6, 2, that's 7, 3, that's 8. 8 is a full shell, so it stops. If it gains 3 electrons, it has a -3 charge. So, our nitrogen has -3. Are we balanced? Surely we are not. So we need to add more on the silver side because there's only +1 to nitrogen's -3. So we're going to add silver. There we have it. Now we have +3 +3 minus 3 equals 0. We are balanced, so we're going to need 3 silver and 1 nitrogen to give us Ag3N. If our name is silver nitride, our formula is going to be right here, Ag3N. Let's go the other way. What is the name of indium 3? Oh, no, I just did that. What is the name of In3O2? That's what we should ask. What is the name of this compound if this is its formula? Well, we look up the symbol. In, what's that name? It's indium. What's the O? It's oxygen, but it's an anion, so it becomes oxide. Now, do we need parentheses? No, because it's a simple 6 metal. We're done. Naming the simple 6 metals are just as easy as naming the original metals. And that's it. This is it for the simple 6. I hope this helps. Struggle well.